So let's kind of take a look. So here, I'm going to actually start off by talking about amounts of change language. I know that's not the one we generally want to go to first, but let's do it. Amounts of change language, because that one actually helps us with our rate of change. So when we're doing that, remember, so we want to take this and break it up into its pieces. But a lot of times people will say, you go more time, more distance in less time, something like that. Actually, you don't want to change both of those quantities. So for example, if I asked you guys who's faster, I can run 525 feet in 19 and a half seconds, or my friend can run 2,965 feet in 321.4 seconds, right? In that situation, you'd look at me and you'd be like, I don't know. You guys didn't run for the same amount of distance or the same amount of time. And probably what you would do is you'd put those into a calculator and you'd tell me what our unit rate is. You'd be like, oh, well, you ran this many feet per second and your friend ran this many feet per second. And so that person's faster. But when you're doing that, you're converting both of those things into feet per second. So you're holding the per second, the 1 second constant. So when we do amounts of change language, we want to hold one of these changes constant, and usually we're holding the input one. So what I mean by that in this context, I'd be saying something like, hey, every second, right? Or for equal changes in time, right? That's kind of like the two ways I might go about it. But I'll stick with every second, right? I'm going to say dot, 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 because this is going to be true for all 4 of my graphs. So every second, if I start here, we could say that the distance is increasing, right? Because as time is increasing, the distance is increasing. But we'd be saying by larger and larger amounts. So that's what's going on here. And what we can do is we can kind of graph this. Like in that first second, you cover almost no distance. In the next second, you cover just a little bit of distance, right? In the next second, right, a little bit more. In the next second, a little bit more. We get to our curve here and we can really start this next one. I don't know why I always give sound effects, right? But for every second, if these little vertical pieces represent our changes in distance, so every second, our distance is increasing by larger and larger amounts because it's going up, and the length of these lines is representing that distance traveled every second. So every second, we're traveling a larger and larger amount of distance. And if you think about it, if we put that back into, right, our rate, if this is staying the same, but this is getting bigger, then this whole thing is getting bigger, which is why if we were talking about it with rates of change, we'd be saying that that rate is increasing. And we'll come back to that in a minute, but just throwing that out there. All right, let's keep going. So for this next one down here, as for every second that passes, right, we'd still be saying that our distance is increasing. But in this situation, we'd say by smaller and smaller amounts. Oops, totally forgot a word. And smaller amounts. So the distance is still increasing, right? Like if we're talking about like you were at a stoplight and the light turned green and you started traveling, your distance is still increasing. You're traveling away from that stoplight, but now you're slowing down, right? You're going away by smaller and smaller amounts, right? So in that first second, right, your distance increased by quite a bit. In that next second, the distance still increased, but by a smaller amount. The next second, by a smaller amount, right? And so on and so forth. So these changes in distance are still positive, but they are decreasing. All right, let's go over here. So still every second, right? Now in these two graphs, we would be saying, I don't think I did this. This is really a continuation. Sorry, I often put that to remind us that it picks up from every second. So in this one, we'd be saying every second, the distance is now decreasing. And then what we would say here is we'd be saying it's decreasing by smaller and smaller amounts. And so this can get confusing for us because we're like, oh, if the distance is decreasing by smaller and smaller, we just hear the smaller and smaller. But we need to remember that when we see decreasing, that implies like a negative sign on it. So that's the thing that we got to be careful of. But if we did here, we'd be saying, okay, for that first second, your distance decreased by quite a bit. In that next second, the distance decreased, but by a slightly smaller amount, right? Same thing here, and so on. So these changes in distance are negative, but they are getting less negative, right? So maybe this change in distance is like 10 feet versus like 7 feet versus 5 feet versus 3 feet, 2 feet, 1 feet. So we are decreasing our distance, but by smaller and smaller amounts. And sometimes, by the way, a great strategy is make up numbers. Sometimes that will help you kind of wrap your brain around the situation, just so you know. All right, then finally for our last graph, for this one, we'd be saying, okay, every second that passes, the distance is decreasing still, right? But now it's decreasing by larger and larger amounts. And again, if we break this up, right, in this second, our distance barely went down. Next second, went down a little bit more. The next second, slightly more, right? Oh, now it starts to decrease more, right? And then finally here. So those changes in distance, right, all those little ones, you can't even see that one, right? These changes in distance are getting more and more negative, right? So like if this was -1, -2, -3, -5, -10, right? That kind of idea. So every second, the distance is decreasing by larger and larger amounts. So this is my amounts of change language. We're breaking that rate up into its pieces. But actually by doing this, it helps us understand actually the rates better.